Hello students, AS level chemistry, chapter is chemical bonding, lecture number 5. In this lecture we are going to study a very important process of polarization. We will study what is polarization. Second thing, we will study what are the factors affecting polarization, and then we will discuss some questions that are commonly asked about polarization in your exams. Okay, let's start. First of all, you must remember what is polarization. Polarization is a property of ionic compound. It is a process that takes place within ionic compound. Now, what you know, an ionic compound, it is made up of positive and negative ions. Positive ions, they are always smaller than their respective atoms. Why a positive ion is smaller than its respective atom? Because during loss of electron, one complete shell is removed. Compared to a positive ion, negative ions are always bigger, they are larger compared to their respective atom. Now, why a negative ion is bigger? It is larger compared to its atom because during the gain of electron, an inter-electronic repulsion takes place, and that inter-electronic repulsion, it is responsible for the dispersion of electronic charge. And when electronic charge is dispersed, the radius, the size of the negative ion, it is increased. So this is a general fact. Positive ions are always smaller, negative ions are larger in an ionic compound. Now what happens due to this small and large radius? Positive ions, they become able to attract negative ions towards themselves strongly. When positive ion, they attract negative ions toward themselves strongly, what happens? The negative ion cannot retain its normal circular spherical shape. The negative ion, its shape is deformed, its shape is distorted. So from the normal spherical shape, a negative ion, it can become slightly oval shaped. So this area that you can see, it is representing the distortion or deformation of the negative ion. Now this distortion or deformation of a negative ion by a positive ion in an ionic compound, it is known as polarization. So you must remember, polarization is a process of distortion or deformation of a negative ion by a positive ion in an ionic compound. Next thing you must remember, always positive ion causes polarization and negative ion undergoes polarization. So the ability of a positive ion to cause polarization, it is known as polarizing power. The ability of a positive ion to cause polarization is known as polarizing power, and the ability of a negative ion to be polarized, to undergo polarization, it is known as polarizability. It is known as polarizability. So you must remember, polarizing power is the ability, it is the property of positive ion. Polarizability, it is the property of negative ion. Now then, next thing what you must remember, whenever in an ionic compound polarization takes place, polarization, it induces covalent character in an ionic bond. What is covalent character? You people know, during the formation of a covalent bond, shells of atoms, they overlap each other. In this case, you can see when distortion of negative ion has taken place, right now, no doubt, the two shells of negative and positive ion, they are not overlapping, but at least the shell of negative ion, it has come slightly closer to the positive ion. So it means some percentage of covalent character has been induced into this ionic compound, and that covalent character, it is always induced due to the process of polarization. So what you must remember, you must always remember that very interesting and very surprising information that there is not even a single ionic compound that is 100% ionic. Every ionic compound, it has small percentage, if it has small percentage or it has some percentage of covalent character. Due to what? Due to the process of polarization. So always remember, every ionic compound, it has covalent character due to the process of polarization. So there is not even a single ionic compound that is 100% ionic. Now next thing comes, do all the ionic compound, they have equal percentage of covalent character? No. Remember, polarization is a term that is used for comparative analysis. If I give you a single compound and if I ask whether it would have polarization or not, you can say it would have polarization because every ionic compound, it has polarization. But how much polarization? We cannot tell. We can tell polarization comparatively. We can make a comparative analysis whenever we have been given two or more than two compounds. Then we can tell this compound can have more, this compound can have less polarization. Now how you can decide which compound can have more polarization and which compound can have lesser polarization? For that purpose, you will have to remember the factors. Remember, polarization depends on polarizing power of positive ion and it depends on polarizability of negative ion. So what are the factors to decide polarization? Which positive ion suits us for polarization? A positive ion that is highly charged and small in radius. If you have been given two or three ions, comparatively you will look at which positive ion is highly charged and which positive ion is smallest in radius. That positive ion would have maximum polarizing power. It can cause polarization to a greater extent. And if you have been given two or three negative ion, comparatively you will look at which negative ion is highly charged and having largest radius. Whenever a negative ion is highly charged having largest radius, it has greater polarizability. It can undergo polarization to a greater extent. So these are the factors of positive and negative ions that you must remember, which are responsible for maximum polarization. A compound can have more polarization whenever positive ion is highly charged and small radius, negative ion is highly charged and large radius. Now let's apply these factors and discuss few questions. But remember, again I am telling you, this polarization, it is a relative term. It is used for comparative analysis for two or more than two ionic compound. But this is obvious that every ionic compound has polarization to some extent. Okay. Look at the first possible question, a very simple question in your exams. You can be given a number of positive ions or a number of negative ions. For example, you can see three positive ions have been given. The typical question can be asked, which one of these three ions would have maximum polarizing power? So simply you will have to remember the factors. Which one of these three ions is having high charge and small radius? It is aluminum. Aluminum is having high charge and it is having small radius. Why it is having small radius? Because number of protons in aluminum are maximum. So there is strongest nuclear pull. So aluminum is having high charge and small radius. So it would have maximum polarizing power. Second thing, in some cases you might be given a set of compounds of elements. For example, you might be given NaCl, MgCl2, AlCl3. Now comparatively it can be asked which one of them would have minimum and which one of them would have maximum polarization. Simply you can see NaCl would have minimum polarization. Why? Because sodium is having low charge and aluminum chloride would have maximum polarization. Why? Because aluminum is highly charged and it is having small radius. So what you can remember, generally speaking, it is a fact, every ionic compound has polarization, every ionic compound has covalent character. But in these three compounds, sodium chloride would have slight polarization, slight covalent character. Compared to sodium chloride, magnesium chloride would have some covalent character, some polarization. Obviously, this magnesium chloride would have greater polarization and greater covalent character compared to NaCl. And aluminum chloride would have maximum polarization, maximum covalent character. Aluminum chloride, it has polarization to such an extent that its percentage character of covalent bonding, it becomes approximately 50%. Whenever an ionic compound gets approximately 50% covalent character, we start classifying that ionic compound as covalent. So another surprising information, you must remember, it is possible that an ionic a metal and non-metal compound can be covalent compound. Why? Whenever there is enough polarization, that polarization, it has induced approximately 50% covalent character, we start classifying that type of ionic compound covalent. So you can remember aluminum chloride is covalent. So whenever this information is given in the question that a metal non-metal compound is it is called a covalent compound, there is nothing to be surprised now. Simply remember that a metal and non-metal compound can be covalent when there is enough polarization, that covalent character approximately becomes 50%. So NaCl in this case has slight covalent character, MgCl2 some covalent character, and aluminum chloride, it has become covalent compound now. Likewise, if you have been given a set of negative ions like phosphorus, P3 negative, S2 negative, Cl negative, now you can be asked which one of these three would have maximum polarizability. Maximum polarizability of a negative ion is the one that is highly charged and that is largest in radius. So which negative ion is highly charged and largest in radius? It is phosphorus. So P phosphide ion, P3 minus, it would have maximum polarizability. Next question. Now again, as I have told you, some information will be given to you. Based on that information, you will have to answer the question. Look at this question. We have been given two compounds of aluminum. One is aluminum chloride, one is aluminum fluoride. It is clearly mentioned aluminum chloride is covalent, aluminum fluoride is ionic. Explain why. So simply what you will say? You will say aluminum chloride has more polarization. Why it has more polarization? Because chloride ion, it is larger in radius, it has greater polarizability. So that is why there is greater covalent character. No doubt aluminum fluoride would also have some covalent character, it would also have some polarization, but that there is not enough polarization that aluminum fluoride, it has lost its ionic nature. So still in aluminum fluoride, the dominant type of bonding is ionic. Why? Because fluoride ion is small in radius, it cannot be polarized easily. So simply in this case you can give the reason based on the factors. Why aluminum chloride is covalent? You will say since it has more polarization, more covalent character, as chloride ion is having large radius. That's it. One more question. This is a common question you people discuss, you people study in O levels. But what is the reason behind this? Now you will come to know. You will come to know now. Look at this question. You people know very common compound aluminum oxide, and all of you know very well aluminum oxide is amphoteric. You people also know what is amphoteric. Any substance that has acidic as well as basic properties, it is known as amphoteric. Now the question is being asked, why aluminum oxide is amphoteric? Let's give an explanation. I am giving you three compounds, three different types of oxides. One type of oxide is sodium oxide, Na2O. Second type of oxide, sulfur dioxide, aluminum oxide. Sodium oxide, as you people can see, it is a metal oxide, and mostly metal oxides are basic in nature. Compared to sodium oxide, sulfur oxide is a non-metal oxide. Non-metal oxide like carbon dioxide, sulfur dioxide are acidic in nature. And as you, this information, it has been given in this question that aluminum oxide is amphoteric. Now what is the reason? The reason is in sodium oxide, why it is basic? In sodium oxide, which bonding is dominating? In sodium oxide, ionic bonding is dominating, because between metal and non-metal, generally ionic bond dominates. It would have some percentage of covalent character, but that is minimum. So whenever ionic bond dominates, the nature of an oxide is basic, and whenever there is covalent bonding, due to covalent bonding an oxide becomes acidic. Now look at this information, and can you guess why aluminum oxide is amphoteric? Yes, you might have guessed. Aluminum oxide is amphoteric because you can write down reasons. Like aluminum oxide, it would have ionic as well as covalent bonding, both bonding approximately equal. Why? Due to polarization. So whenever an oxide is amphoteric, there would be ionic as well as covalent, both type of bonding approximately equal in percentage. So that will induce, that will give amphoteric nature to that oxide. So these are some typical type of question. This is polarization, a very important process. I hope you would have enjoyed this lecture. If you have any question regarding this topic, you can write down your question in the comments. As soon as it would be possible for me, I will give you the answer to that question. Thank you. Bye.